This is lesson 9.6, Dilations. Your objectives are to draw dilations and to draw dilations in the coordinate plane. To draw a dilation, you have to pay attention to the center of the dilation. Typically, the center will be point C. The dilation will either get smaller and become a reduction, or it will get larger and become an enlargement. And it will do that with respect to center C. You'll see how that works as we go. Oftentimes, what will happen is, in an enlargement, the figure will get larger and it will move away from the center. In a reduction, as it gets smaller, it will move closer to the center. The scale factor is how many times the size of the original that the image will be. The scale factor is R. If R is greater than 1, it will be an enlargement. If R is less than 1, it will be a reduction. And if R equals 1, nothing changes. It will be a congruence. So R is the scale factor. If it gets bigger, it's an enlargement. Smaller is a reduction. And if it doesn't change, it is a congruence. Use a ruler to draw the image of the figure under a dilation with center C and the indicated scale factor R. For number 1, R is 3/2. To do the dilation, draw from C to each vertex of the figure. Each of those lines represents a value of 1 because the size hasn't changed. Right now, that is the original size and the original distance away from C. Now I'm going to use the scale factor, which is 3/2. So I want to take each of these distances and multiply them by the factor of 3/2. So each segment will grow 1.5 times larger than it is now. So if you imagine, right now, this segment, that's 1. I need to add 1/2 of that to it because R is 1.5. So you can eyeball it. That much is 1/2. So add that much of the segment to the end of it. And that will be one of my new endpoints. The one at the bottom, that's 1. I need to add 1/2 to that, that's about the halfway point. Let's add 1/2 of it to the end. There's another vertex. The one in the middle, that much is 1. There's about 1/2 of the distance, so I will add that to the end of it, putting it about right there. Again, I did 1.5 times the length of each segment. Connect the dots, and I'll outline that in green so it stands out, and it's obvious. That is my image. Each side of the image is 1.5 times the size of the pre-image, and each vertex is 1.5 times the distance away from the center. Number 2, R is 2/3. Since R is less than 1, this will be a reduction. we will bring every segment back to the 2/3 mark. Just like before, draw from C to each vertex. And on each vertex, or on each of these segments, imagine them cut into thirds. So that one is cut into thirds. That one. That one. And that one. Just do the best you can there. Now we're looking for the 2/3 mark. So I will go from C to the 2/3 mark on each one. Right there. On the second one, go to 2/3. 2/3 on the third one. 2/3 on the last one. So each of these is 2/3 of the distance away from C. And if I connect the dots, my image has sides that are 2/3 the length of the original side. Graph the image of each polygon with the given vertices after a dilation centered about the origin. So the center will be the origin with the given scale factor. So my center will be the origin. I'll draw the pre-image in green. Point A is 1, 1. B is 2, 3. C, actually it's point C is 2, 3. D is 4, 2. And E is 3, 1. There's my pre-image. We'll blow that up some to make it stand out more. Now we will draw from the center to each vertex, to A, to C, to D, and to E. They told us that R is 0.5. So on each of these, I will be cutting the distance in half, which is a lot easier to do on the coordinate plane because you can use the grid to help you. From the center to A, that's one diagonal. I will go to the halfway mark on that diagonal. From the center to C, I can see the halfway mark will be about right there. From the center to D, right there. And the center to E, right there. I can draw my image. I've got my new points, A prime, C prime, D prime, and E prime. Each vertex is half the distance from the center, half because R is half, and each side is half as long as the sides on the original. On this one, again, the center is the origin. My pre-image uses point Q at -1, -1. R is at 0, 2. S is at 2, 1. The scale factor is 3/2, so each side of the new figure will be 1.5 times as big, and they will be 1.5 times the distance away. We'll blow that up a little bit. Let's go ahead and draw from the center to each vertex. And we will go 1.5 times the distance away. From the center to Q, I'm going 1 diagonal. Let's make that 1.5 diagonal. So take a half a diagonal to the end of it. And there's Q prime. From the center to R, I'm going up 2. 2 times 1.5 is 3, so we'll add 1 to the end of that. There's R prime. From the center to S, I'm going over 2, sort of, at that diagonal slant there. So I'll add 1 more to that because 2 times 1.5 is 3, so now I'm 1, 2, 3 diagonal bits over to S prime. And there's my bigger triangle. Each side is 1.5 times the length of the original, and each vertex is 1.5 times the distance away from the center.